Hello, in this video I'm going to solve the following problem for you. State that whether the following integral converges or diverges, and justify your claim. Integral from minus pi over 2 to pi over 2 cosecant x dx. That would be a good idea if you pause the video at this point and give it a try yourself. Okay, now let us solve the problem. So you see that this integral is indeed an improper integral of the second kind, because number 0 is within this interval, and cosecant of x, which is 1 over sine x, becomes problematic at x equals to 0. It becomes unbounded. So this function f of x, the integrand here, is 1 over cosecant of, 1 over sine of x. Cosecant means 1 over sine. And then, for example, if I take the limit of this function, x goes to 0 from the right-hand side, it becomes infinity. And for example, if I take the limit of this function, then x goes to 0 from the left, it becomes minus infinity. Because in that case, x will be in the fourth quadrant, sine is negative. In this case, x will be in the first quadrant, and then sine is positive. Okay, and then I understand that 0 is the problematic number, so I consider two different integrals. One from minus pi over 2 to 0 cosecant x dx, and one from 0 to pi over 2 cosecant x dx. Okay, so we need to understand these integrals. Of course, if one of them is divergent, we don't need to do the other one. We can conclude that the original integral is divergent. But if both of them are convergent, then this integral also converges, and the sum of these two integrals is equal to the value of this integral as well. Okay, so let us concentrate on the second part. So integral from 0 to pi over 2 cosecant x dx. This can be written as integral from 0 to pi over 2 1 over sine x dx. And then within the interval 0 to pi over 2, actually I have a famous inequality. So if x is between 0 and pi over 2, sine x is less than or equal to x. In order to prove this, I can say that, okay, let us define another function, let me call it h of x, to be sine x minus x. I define this function, and I differentiate it with respect to x. The derivative of sine becomes cosine, the derivative of x becomes 1, so it becomes cosine x minus 1. But I know that cosine is maximally 1, so cosine x minus 1 is always negative, or at most equals to 0. This means that h is decreasing function. H is decreasing. Of course, h is decreasing on any interval, including the interval that I am interested in. Okay, so if I concentrate on this interval, I know the function h I defined there is indeed decreasing. So this means that if x is greater than or equal to 0, because h is decreasing, it means that h of x is less than or equal to h of 0. Well, what is h of x? H of x is the expression I defined there. So it becomes sine x minus x is less than or equal to h of 0 is the same expression. X's should be replaced by 0. But of course, this expression is nothing except 0. So sine x minus x is less than or equal to 0. This means that if I move x to the other side, it means that sine x is less than or equal to x. Yes? But I want to know something about 1 over sine x. Within this interval, I can safely find the reciprocal and reciprocal. So 1 over sine x and 1 over x, because the denominator of this fraction is less than the denominator of this fraction, this expression, and by the way, both of them are positive, because in the first quadrant sign is positive and x is also positive, so then it means that this one should be greater than or equal to that. Okay, so and now instead of calculating this integral, what can I do? I can go and talk about the integral from 0 to pi over 2 of 1 over x. So let us concentrate on this integral now. 0 to pi over 2, 1 over x dx. Of course, this is very famous that this integral diverges to infinity. There are theorems in the book that you can use that. But if you want, you can also do it from scratch by writing, say that, okay, this is the limit of integral. Instead of 0 to pi over 2, I write epsilon to pi over 2, 1 over x dx. Epsilon goes to 0 from the right. But this is so simple. I copy and paste this limit part. Integral of 1 over x becomes ln of absolute value of x, going from epsilon to pi over 2. Yes? So then it becomes the limit of ln of pi over 2, I don't need absolute value sign, minus ln of epsilon, I don't need absolute value because epsilon goes to 0 from the right, so it is positive. And I now take the epsilon goes to 0 from the right, but I know that limit of ln of epsilon when epsilon goes to 0 from the right is negative infinity. So this becomes positive infinity, and this is a finite number. So the answer is positive infinity. So, and now because this integral diverges, and this integrand on that interval is greater than or equal to 1 over x, and both functions are positive, this means that the integral of this one within the same interval also diverges to infinity. So, thus, integral from 0 to pi over 2 cosecant x dx diverges to infinity. Okay? Anyway, this means that this integral is divergent because at least one of them is divergent. For this problem, calculating the integrand is also very standard. I hope that you know this. For example, if I ask you, let us do it in a different way. I still believe that this is the better way because we don't need to calculate the primitive function. But here, let me start tackling the problem from the beginning and say that, okay, I write the definition, integral from epsilon to pi over 2, and then I have cosecant x dx. Epsilon goes to 0 from the right hand side. But what is the integrand here? Okay, so let me think a little bit. I have some part of it in my memory. So it becomes ln of absolute value of cosecant x plus cotangent x. I have to make sure that if the sign is positive or negative. So if I differentiate this, the derivative of that becomes negative, so it should be negative here. Yes. And then I have to run it from epsilon to pi over 2. Then you see that it will become a little bit problematic, yes? That's why that method is better. Because if I want to do it, what should I do? This is the limit, epsilon goes to 0 from the right hand side. I put pi over 2 there, so it becomes ln of cosecant pi over 2 plus cotangent pi over 2, and then plus ln of cosecant epsilon plus cotangent of epsilon, and epsilon goes to 0 from the right hand side. But cosecant pi over 2 is 1. Yes, it's 1 over sine of pi over 2, and sine pi over 2 is 1. And cotangent pi over 2 is 0. So ln of 1 just becomes 0. And now I have to calculate this limit when epsilon goes to 0 from the right. Both of them are positive because epsilon will be in the first quadrant, so I don't need the absolute value sign. So this becomes the limit of cosecant epsilon plus cotangent of epsilon. Epsilon goes to 0 from the right. Okay, so we have to calculate this limit. Oh, sorry, I forgot to write ln. So there's an ln here. Okay, so this becomes the limit of ln. This becomes 1 over sine. This becomes cosine over sine. So let me take the common denominator sine epsilon, and then 1 plus cosine epsilon, and epsilon goes to 0 from it. Yes. Okay, so now what happens? The numerator becomes 2, the denominator becomes negligible, it is 0, and this becomes positive infinity, and ln of positive infinity also becomes positive infinity. So in this case, we could actually calculate the integrand and then don't use the comparison tests. But still, I believe comparison test here is simpler. Especially these inequalities are very famous. It is always good to remember them when you are dealing with these kinds of problems. Okay, but it doesn't mean that my original integral also diverges to infinity. Yes? Yeah, this one diverges to infinity. Because this one diverges, without considering this, I can jump and draw the conclusion that the original integral by definition diverges as well. Because this integral converges if by definition, if and only if both of them converge. Okay, but now let us see that. Can we say that the original integral also diverges to infinity? The answer is no, because let us try to understand this integral. So this integral from minus pi over 2 to 0, let me write 1 over sine x dx. Yes? So what can I do now? Let me change first of all, you know that this is problematic again. So by definition, this becomes the limit of minus pi over 2 to, say, delta 1 over sine x dx. But this time delta should go to 0 from the left. That's the definition of this improper integral. Okay, so I don't want to start everything from scratch. Let me change a variable here. So for example, let me introduce capital X to be minus x. Okay, so then it means that d of little x is minus d capital X. And then when little x goes from minus pi over 2 up to delta, this means that capital X goes from pi over 2 to minus delta. Yes? If x is minus pi over 2, I put it here, capital X becomes pi over 2. If with delta, it becomes minus delta. So then it means that I can write this as the limit. Delta goes to 0 from the left. Integral, instead of minus pi over 2, I just simply write pi over 2. Instead of delta, I put minus delta. And then it becomes sine of minus capital X. And then I will have minus dx. Yes, is that right? Okay, but sine of minus at an angle, minus sign goes out from sine. There is a minus sign here, they will cancel out. So this becomes the limit of delta goes to 0 from the left. Then it becomes integral from pi over 2 to minus delta 1 over sine capital X dx. But now you see what happens. I can introduce epsilon to be minus delta for this limit, and then this limit becomes the limit of epsilon goes to 0 from the right. Because epsilon is minus delta. If delta goes to 0 from the left, epsilon goes to 0 from the right. And then what happens? This becomes integral pi over 2 to positive epsilon 1 over sine x dx, and then I interchange these limits, and then I have an extra minus sign here, so this becomes the limit, and that minus sign, if you don't mind, let me pull it out, and then it becomes integral from epsilon to pi over 2 1 over sine x dx, and epsilon goes to 0 from the right. But of course, this is exactly that integral. The only difference is that little x is replaced by capital X now. So we know that this limit is infinity. There is a minus sign here, so it becomes minus infinity. So this means that this integral, this part of this integral diverges to plus infinity. This part of integral diverges to minus infinity. So we cannot say something definite for that integral, because that integral is indeterminate of the form infinity minus infinity. Okay, so we cannot say that the original integral diverges to plus infinity or minus infinity. We can just simply say that the original integral diverges. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.